regular and irregular polygons. Firstly, Sukana, can you tell me what is polygon?
Yes, ma'am. A polygon is a two-dimensional figure.
Figures that are plain, flat surface, yes, that are in a straight lines, that are in a closed shape with the closed curves. Okay, so what shapes and what things makes a regular polygon, and what shapes and what things makes an irregular polygon?
The triangle, quadrilateral, pentagon make regular polygons. Circle, cone, cube.
Triangle, you told me that triangle is a regular polygon. How a triangle, and which triangle is a regular polygon? Isosceles triangle, very good. And a square, why the isosceles and the square are the regular polygons? Is there any specific thing about that? Any important point which makes a regular point? Because
they have closed line.
no, we also have a rectangular. We also have a rectangular, which is a straight line, which has a straight line. They all are
have same measurement.
Yes, they are in same measurement. Yes, they are equilateral and they are equiangular. Equilateral means they have the same sides in same length. Each line is equal in length with each other, and equiangular means every corner, every edges has the same angle. That's why these things makes a regular polygons. Okay, so a regular polygon is both equiangular, and we have done with this. Now on the next page, these are the few shapes which are not polygons. Okay, here we have a rectangular polygons. Which one is 1 2 3 4 5, which is pentagon, and 1 2 3 4 5 6, which is hexagon, because every angle and every side is equal in measurement, and that is a regular polygon. And the polygons that are not regular, because they have a different angles, different in length. Okay, so there is a sign we use, double line or simple line indicates the segments of equal length. Okay, if we have a same length in whole shape, then we can use a single line to represent, or maybe double line. If we have a two different length of the straight lines, then we have to use the double and the single separately to show them. Okay, is there a triangle that is equilateral? Now this is the question. Is there a triangle that is equilateral but not equiangular? Why triangle is equilateral but not equiangular? They are telling, they are asking a question, that is there any triangle that is equilateral but not equiangular?
Yes.
No, we don't have any, because
we have equilateral triangle.
We have the triangle that is equilateral and equiangular, but we don't have any triangle which is same in the side but different in the angle. No. Why? Because there is no triangle that is equilateral but not equiangular. If we have a triangle which has the same angle and that triangle is not in the same line, that is a very difficult thing. For example, now this is the screen I have. Okay, is my screen visible to you? Whiteboard?
Yes, ma'am.
Yes. If I have a triangle like this, okay, this is not equilateral because every side is different. These two are similar with each other, but this one is different. This is equiangular because here is angle is different, here is angle different, here is angle different, and the sides are also different. Okay, so firstly we have to get the information about the equilateral triangle. Definition: an equilateral triangle is a triangle where all the three sides are equal length. For example, this is a triangle which is equilateral. Why this is equilateral? Because all the sides are, you don't have to write anything, I will tell you which thing will be written. Okay, you just have to listen to me. Okay, what is equilateral? Means the same sides of any shape, any triangle. And equiangular, in any equilateral triangle, the quantity of the sides ensure that the three angles are also equal. If there is a triangle which is equilateral with the same side but does not have a different but have a different angle, that such triangle does not exist. Okay, why? Sum of angles in the triangle, equal side implies equal angles. Equilateral because whenever you have to sum the angles, all the angles will be contributed and we have the one angle of a triangle. Okay,
Okay.
an equilateral triangle is always equiangular because the property of having all the sides equal automatically ensures that all the angles are equal. Okay, if you are going to say to me that if we have a triangle which has equal sides but angles are different, that is not technically possible. Why? If the sides are all equal, for example, if I give a triangle which sides are equal, does this sense make that
No.
the angles will be different? Angles should be same because the lines are the same. Okay, so there is that such kind of triangle doesn't exist. Okay.
Okay.
Okay, good. Now we have to move to the next question. Angle sum property. For example, if we have any shape, basically we just have to calculate the angles of triangles, square, possibly square, but square is just another case. Okay, we just have to calculate the angles of triangle. That is a compulsory question. Okay, angle sum property. Do you remember the angle sum property of triangle? Have you done this topic before?
When we have done it, but not fully.
Okay, the sum of the measures of the three angles of a triangle is 180. If we have any triangle, okay, that is isosceles, that is a scalene triangle, any triangle, the sum of all three angles should be
180.
180. Very good. For example, this is a triangle. Which triangle is this? Can you name the triangle?
Okay.
No, this one is right angle triangle. This one is right angle triangle. This one is right angle triangle because angle here is
Right.
90. Angle is 90. Is it? Angle is 90. Now here we have an isosceles triangle. When we add each angle, that will be, I guess, 45. Here we have 45. Here we have, I guess, 60 something. Then we have the sum, which is 180. Okay,
Okay, ma'am.
and at last we have this kind of scalene triangle, just like this, which is also the sum of 180. Every triangle, rather any shape, any size, the sum of all three angles will be 180. And how we can add these sums? That is the critical question. Okay, before going to the next topic, we have to write the few things about the regular, irregular polygons. Have we done this topic in the previous class?
Regular, ma'am, we wrote about polygons, but
Okay.
that not
We don't have.
regular.
Okay, so today we have to write about the regular and
Ma'am, we
irregular.
wrote about regular, but not irregular.
Okay, today we have to do the irregular polygons. Okay, just start writing after the irregular polygons. Okay, irregular polygons.
Yes, ma'am.
Okay, so the definition of irregular polygon is A regular polygon has all the sides of same length and all. No, this is a regular. We have to do the irregular. The irregular polygons, the shape that does not have the same sides. Irregular polygons are equiangular but not equilateral, like rhombus, rectangle. And how we can represent the same angles with the same sides? By drawing these lines, double lines, okay. And by doing this for the equilateral, if there is a different sizes, if there are different length, maybe angles in the different, we have to represent like this, okay. Now we have to do the exercise. Now we have to do the angle sum property, how we can add the angle of any shape, okay. Now we will start from the triangle. This is basically a triangle, okay. Triangle has how many sides?
3 sides.
3 sides, okay. Now here we have an angle, here we have an angle, and here we also have angle, but we don't know the exact value of an angle, so we have to calculate, and then when we calculate the angle, then we have to sum up, okay. We know that the right angle triangle is consist of 90 here, and how many angles are there will be?
2.
The two angles, another two angles.
Yeah.
How, what are the other two angles?
180.
They are 180, but collectively they are 180, but what will be here and what will be here? There is a 90 and other two angles. If we have a total is sum of 180, then here we have 90. So how we can calculate the other sides of an angles of triangle? If I have to find how? If this is a simple trick, if you have a one angle in a triangle, any shape, you can subtract that part of angle to the whole part, okay. If I have to subtract the 180, that is the whole sum of a triangle, with half of it, which is 90, then I got how many numbers? 180 minus 90, is it 90? Is it 90? It's 90, but there is a 90 on other sides, but here we have two different angles. How I can represent the two different angles? Here I have to put 45, and here I also have to put the 45, which makes a total angle which is 180, okay. Got
Okay,
it?
ma'am.
Got it?
Yes.
So if you have to find the other two angles of any triangle, you have to subtract that part from the total angle, so you can get the other twos, okay. And you also able to do that, how we can distribute angles. Remember that, not less than 180, not greater than 180. You have to write this thing down, how we can sum up the angles, okay.
We can.
Next question is, what is the angle distribution in isosceles triangle? How we can distribute the angles in isosceles triangle?
1 minute, I'm writing down.
Okay, you can write it. Done.
No, I'm all.
That what are the key points? What thing is isosceles triangle is equilateral and as well as equiangular?
Yes.
Yes. Okay, if there is equiangular, it's mean that all the angles of this triangle should be equal with each other, and the sum should be equal to, and the sum should be equals to
180 degrees.
180, not degree, just 180. Okay, no, how you can divide this 180 into three angles with the same number? How?
180 divided by 3.
Divided by, how you can divide 180 by 3? Okay, 180 divided by 3, what will be the answer? Okay, and that will be the equal angles should be distributed in three sides of this triangle. Okay, sixty. Then the isosceles triangle contains 60 angle on each side. Okay, this is the best way to find. Done.
Yes.
You can write it. Done. Point 1 we have done with the third chapter, the revision, the topic. We have learned everything. This exercise will be include the few topics of your topics that we have learned, so we can do this exercise. Give here are some figures. We have some figures which are the given. Classify each of them on the basis of the following. We just have to define them, which is the which shape. Okay, first one we have the A, simple curve, simple closed curve, polygon, convex polygon, and the concave polygon. Okay, so the figure 1 is which? Is it polygon? Is it simple curve? It is simple closed curve, or is it convex polygon, or it is concave polygon?
It is an concave polygon.
It is concave polygon. Okay, can we use the same name twice? First one is you told me that it is concave polygon because we learned that we have a concave polygon which one side will be inverted. Okay, but if I told you that is also a simple closed curve, is it?
Okay. It's easy to identify as a concave polygon.
Yeah, it is a concave polygon. Okay, you have to write it down. On the first picture you have to write E. You can put that E inside the picture. Okay, E, concave polygon. Okay,
Okay.
on the next 2,
It is a polygon.
it is also polygon, but it is also a simple closed curves, and it is also a convex polygon because all the sides are outward. So it gains three names. It is also a polygon, it is also a simple closed curve, and it is also a convex polygon. You can use these three names for the second diagram, okay?
And con.
You don't have to write the full name, you can just put A, B or C. For example, this is a simple closed curve, then you have to put the B, you have to put the C, and you have to put the D. Okay, you don't have to write the full names, you just put A, B, C. Okay,
Okay.
B, C and D. So good, move to the next part.
Yes.
3. What is the 3 diagram?
It's a simple closed curve.
Okay, it is also a simple closed curve, it is also a simple curve. I think A and B will be suitable for the third one.
Simple curve, simple closed.
Yes, A and B both for the third one.
हमें इसे कलर करना को
Done? Okay, what it will be for the figure 4? That is a star.
Convex polygon.
No, convex polygon. It is inverted in the one side.
Oh yeah, it is.
Concave. It is a concave polygon. It is a polygon. It is a simple closed curve, and it is a simple curve. You just have, you don't have to put the D part. A, B, C and E is suitable for 4 1. Is it?
Yes.
Yes, very good. The figure 5th, which is like two circles but are separated from the separate one, from the bottom. Okay. Okay, for the figure 5, it is a simple curve. Is it?
Yes.
It is a simple closed curve. Is it?
Yeah, ma'am.
Or is it a polygon?
I don't think it's a polygon.
No, if it is not polygon, that it does not also, it doesn't have convex and concave polygon. It is simple curve and simple closed curve. For the 5th diagram, we have A and B. Okay, so
Sixth one is also doesn't look like a
yeah,
polygon.
6 1 is a simple curve and simple closed curve. 6 1 is also belong to the A and B part. Very good. And the figure 6, it is also a simple curve and simple closed curve because it doesn't belong to the polygon. If it doesn't, then it cannot also belong to the convex and concave polygon. Now the figure 8.
It is the figure 7, right?
Yes. What is the 8 diagram shows? No, it is not a polygon. It is not a polygon. It is not a polygon, and it is not a simple curve, and it doesn't belong to the simple closed curve. So the figure 8 has nothing.
And this one.
Figure 8.
It says
How many diagonals does each of the following have? Now if we have a convex quadrilateral, you can pick any convex quadrilateral from the topic of the convex quadrilateral, a regular hexagon and a triangle. Now you have to open your rough register, you have to draw the diagram of convex quadrilateral, you have to put the page, you have to set the page, you have to mention the date. Have you done with this already? You just have to
already pictures of those in the textbook.
Okay, can we just write the question number 2 of exercise 3.1 and part 1? Can you?
Remember this the pictures and everything given for in the textbook.
In the textbook, yes, you just have to find the picture of convex quadrilateral. Can you draw the only picture of convex quadrilateral on your rough notebook, and you have to draw the picture of regular hexagon on your rough notebook, and same thing for the triangle. When you're done, then you have to show it to me. You have to draw the diagonals of these three pictures. First one is convex quadrilateral. Can you show me the convex quadrilateral that have you drawn? Convex quadrilateral. That is a convex quadrilateral. How many convex quadrilateral diagonals do diagonals have? How many diagonals?
4.
4. No, 2. Convex quadrilateral has 2 diagonals from the opposite sides. Yes. And what about the regular hexagon?
9.
9. Can you show the diagram? Yes, just like that. Okay, how many diagonals do triangle have?
0.
Triangle, 0 diagonals. Triangle does not have any opposite sides. Very good, correct. So on the question number 3rd, what is the sum of the measures of the angles of convex quadrilaterals? What is the sum of measure of angle of convex quadrilateral? Is 360. And will this property hold if the quadrilateral is not convex? Mean it if it is concave? Yes, because concave is still a quadrilateral. It just give an inward direction, and convex give an outward direction. Okay, and make a non-convex quadrilateral and try. Now we have to do this. Here firstly we have to draw the convex quadrilateral. For example, convex quadrilateral just like this, you have draw this just like this. Okay, if I have to split this is convex quadrilateral. Okay, this is the answer of question number 3rd. This is a convex quadrilateral. If I have to split this convex quadrilateral, then this angle will contain 180, this contains 180, and the sum of 180 is 360. So this property is for the convex quadrilateral. First I have to write and complete, then you have to write after this. Okay, for the non-convex quadrilateral, for the non-convex quadrilateral. For example, this is the picture which is the best example for non-convex quadrilateral. If I have to split from here, then it will look like a 2 different triangles, and one triangle is sum of 180, another one is the sum of 180. So sum of 180 is 360. Now we have to write the answer. The sum of the measures of answer
180.
Yes, the sum of measures of the angles of the angles of a sum of the measures of the angles of convex quadrilateral is 360. Okay, and this property you have to just repeat after me, you don't have to write. Sukaina, this property
The
holds
sum of this property holds
true even if the quadrilateral is not convex.
It's not convex.
And we have already give the reason with the picture. Now you have to write it down. So in the question number 4 we have to examine the table, then we have to solve the sum of the convex polygon with these sides. Okay, for example 7, 8, 10 and n. We have provided from the 6 and the last one is 6. You have to continue from the 6. For example 6 contains 4 multiplied by 180. We have to minus the 1 digit from the 2 and answer will be multiplication by the 180. Now we have to draw the table here. For example now we are doing for the part 7a. Okay, you don't have to write, you just have to understand first, then you have to write. Okay,
Okay, ma'am.
first one is a part, which is 7. As you can look from the table, we have to minus the given digit from 2. This is the rule. We have to minus the digit from the 2 and then we have to multiply with 180. We have to multiply with
180.
180. Now 7 minus 2, what will be the answer?
7 minus 2 is 5.
5. Now we have to multiply 5 with 180. Solve this and give me the answer. 5 with 5 zeros are 0. 5 eights are 40. 5 ones are 5. 5 plus 4, 9. 900. Okay. This is the answer. Is it correct?
Let me just
Okay.
note it down.
Done.
Yeah.
You just have to mention the question number 4 from your textbook and you start writing the solution of this on your rough notebook. Okay,
Okay, done, ma'am.
done. Now we have to do the part B.
Which is
Part
done
B,
now.
which is 8.
8.
8. Now we have to minus the 8 with 2 and multiply by 180. What will be the answer if we have to subtract the 8 minus 2?
8 minus 2 it will be 6.
6. And we have to multiply 6 with 180. What will be the answer? 6 zeros are 0. 6 eights are
6.
8s are 48.
1080.
Very good. 1080. 1080. Okay. Now the part C. You have to solve the part C. First done this, then you have to part C.
8 minus 2 will be.
Can I move to the next page? Can I?
Yes, ma'am.
Okay, C. You have to solve the C and give me the answer.
1440.
1440. 10 minus 2 multiply by 180. Then 8 multiply by 180. 1440. Now for the n. Now we have to do for the n. N will be simply like this. N minus 2 multiply by 180. Is it? I think this is the correct answer.
Yes.
Okay. So the
Oh, that's the answer.
question number 4 done. Done.
Yes, ma'am. Done.
Now we have to do the question number 5. What is a regular polygon? State the name of a regular polygons of 3 sides, 4 sides and 6 sides. Firstly, you have to write the definition of regular polygon. We have already did that, but you have to write it again. Okay, you have to state the name of a regular polygon. For example, if we have a regular polygon that has the 3 sides, you have to draw it. Okay,
And what is the definition of a regular polygon? The same definition, right?
same definition. State the name of a regular polygon of 3 sides, 4 sides and 6 sides.
Triangle.
Okay, and for the 4 sides,
Square.
square.
Yeah, it's a regular polygon.
Square is a regular polygon. Okay, you can count as a rectangle or quadrilateral as well. Okay, you can put any name. And the 6 sides.
6 sides is a hexagon.
Very good. You have to draw it and you have to give the name to them. Okay.
Should I draw it now?
Yes, you have to draw it. Yes, we have to measure the angles according to their existence. If there is a 180 degree and sum of angle, if there is a 360 degree of angles. Okay. On the first picture, we have 120, we have 130, and we have 50. And the last angle we have to find the x. Firstly, we have to add all these. Add 120 plus 130 plus 50. Answer is
180.
Answer is 300. Answer is 300. Okay, when you add all these angles, answer will be 300. So, in a quadrilateral, the sum of angles is 360. Is it? But in the given figure, the angles is only 300. What will be the value of x to complete 360 angle?
60.
Very good. 60. That will be x is equal to 60. Then by adding 60, we got the whole sum of 360. Okay?
Okay, ma'am.
Okay, very good. You just have to write the value of x on the book. Okay? Okay, and on the next picture, we have the 60, we have the 70, and we have the 90. When we add 7, 60, and 90, answer is 220. We have to find the next angle, which is the x. And what will be the remaining amount? We have the 70, 60, plus 90. We got the answer of 220. This is the angle which is given. Okay, if we have to find the remaining angle, that will, if the things gets tricky, you can simple do this. From the total amount of angle, you have to minus the given amount.
Okay.
Okay, and the answer 0 minus 0, 6 minus 2, 4,
It is 140.
140. So what will be the x angle?
140.
140. You can write it down. On the seventh figure, we have 70, we have 60, and we have 30, and the answer is total 160. We have to find the values of both x.
200 degrees.
200 degrees, 100 to each. 100 to each. For the D figure, what it will be for the D figure?
Ma'am,
Yes.
that one is
All the angles are not given, but the interior angle of a pentagon sum is. What is the sum of angle of an interior pentagon? No, for the pentagon. That is 540. That is 540. Okay, then if we have the here is a trick to do this. You have to remember that the sum of pentagon is 540. So we have the pentagon, we have to multiply 5x, then here will be 540, x will here, then we have to divide 540 with 5, then the answer will be 5 8s are 40, 5 1s are 5, then answer will be 108. Okay, answer will be 108. Okay.
Okay.